Hello friends, welcome to CEC live lectures. Dear friends, today in this session we are going to talk on software engineering. This is an introduction to software engineering, and for the discussion we have with us in our studios Dr. Pavitra Bharadwaj. Dr. Pavitra Bharadwaj is assistant professor, and she's assistant professor in Department of Computer Science, Jesus and Mary College, University of Delhi. Dear friends, we know that you might have lots of questions while listening to us, and if you wish to ask questions, then do call us through our toll-free number. Our toll-free number is 1800110430. I repeat, our number is 1800110430. All dear friends are requested to call in the last 10 minutes of the lecture only, as well as you are requested to ask questions relevant to the topic. Now, I would like to welcome our guest, Dr. Pavitra Bharadwaj, and would request her to explain us in detail about today's topic. Hello, ma'am. Welcome to the lecture.
Good afternoon. Today we are going to talk about a very interesting and a very important branch of computer science, that is software engineering. This is going to be a series of lecture, today being the first in the series. So, to begin with, what is software actually? So, we understand software as maybe the programs which are running in the computer, or maybe the data, or any intangible components of the computer system. So, basically a software is nothing but a set of programs. If I begin from the basic premise of problem solving, so whenever we have a problem, we have to follow some steps to solve that problem, and the steps that are required to solve a particular problem, those steps, that step by step procedure that is followed, that is known as an algorithm. So, algorithm could be the steps followed to solve any given mathematical problem, or it could be the steps followed to perform a particular task or to undertake a given procedure. So, basically it is nothing but the steps written in a systematic manner of which instruction or which step is to be followed after which step. Now, when you write this algorithm using a programming language, a computer programming language like a C or a C++ or Java or any other programming language for that matter, that becomes a computer program. So, basically a computer program is an algorithm or the steps to solve a problem which is represented using a programming language. Now, when you have a number of programs which are working together, which are working in sync with each other to perform a bigger task or to perform a number of tasks, then that set of programs is known as a computer software. So, basically a software or a computer software can be defined as the collection of computer programs, procedures, rules and associated documentation and data. So, now this definition, it goes beyond the concept of computer program, and it says that a software is not just a program, but it is also the procedures which are followed, the rules which are to be undertaken, and all the associated documents which are generated or which are required for the understanding of the software or for the understanding of the system per se. They all are a part of the software itself. So, it is much beyond the simple software. So, we say in common terms or in common parlance, we say that software is the set of instructions and the associated data that direct the computer to do a task, or that specify the computer on how a particular task is to be done or how a particular problem is to be solved. So, we must understand that a computer system is composed of different components, because we are using the word system. So, it means that it is composed of different components: hardware, software, people, that is the users of the computer, and none of these components is useful without the other. So, therefore, computer hardware will also not be of the use or of any use for this purpose if you are not having the correct software, the right software which is required by the user or by the computer system. So, basically this is how you define software, that is the program, the data and the associated rules, procedures and documents or documentation which is available with the software. Now, if we come to the term as software engineering. Now, software engineering term was actually coined at the NATO sponsored conference somewhere in 1960s in Europe. And this term was actually coined because there was too much of ambiguity and there was too much happening on the software front at that time in the developed part of the country or the developed part of the world. And in order to systematize this development of computer programs and the associated problems that were creeping in, the term software engineering was first used. So, basically now software, when we talk about software, there could be different ways in which software could be understood. Now, if we take two scenarios, one software is, say for example, in a class of computer science, the professor gives an assignment to develop a student management software to the class. So, the students will work on that software, they will develop that software and they may give that software to the teacher. If the teacher has given a time of say 3 months, the students may be able to give it within a time of 2 months only, and say for example, the effort which goes into it is say 5,000 lines of code per person. But if the same student management software is to be developed, is to be built for a client by a professional software company, then the same software, to develop the same software, you may need a time frame of say more than 6 months. So, what is the difference between these two, and why is it that the same software or the appealingly same software will require such different amounts of human effort? This is because the first software, that is a student management software which was developed by a class of computer students, was done for a purpose of demo only, and that was just to show the professor that yes, the software is working. Whereas the software which was developed by the professional software developing company was done for a particular client, and the way the client's business was going to be affected by this software was very crucial, very critical. So, therefore, much more serious effort will go into making of such software, making of such professional software. So, therefore, we use a term called industrial strength softwares. So, industrial strength softwares are those softwares which are built to solve some problem of a client and is used by the client organization to operate some part of their business. Therefore, the industrial strength software must be of very high quality, because it is going to affect the the revenues of a company, of a client for whom the software has been developed. So, therefore, software engineering is a very systematic branch of computer science, which explains in detail about the process which is used, the different tools, different methods, methodologies which will be used for developing industrial strength softwares which are of very high quality and which will meet the specifications, the quality specifications of any professional software. So, in the course of this series, we will be talking about the different aspects of the process, which processes which are employed to create softwares, not just to create the softwares, to deploy them, to implement them at the client's end, and also the post implementation problems and the solutions to those problems will also be discussed as a course of this lecture series. So, now we will talk about basically software engineering is said to be a science as well as an art of building significant softwares which are on time, which are on budget, which have acceptable performance and with correct operation. So, these are the 4 main criteria which are given. On time means if the the time allotted for the development and implementation of a software is 3 months, the software should be able, the company should be able to deliver the same during that period of time. That is, the amount of time required to develop and deploy the software should match with what has been committed. This is a very common problem of this domain of work, that the softwares are often they get delayed. Next is the cost of the software, because we, as in the due course we will see that the users requirements keep on changing, which will often change the way the software development has been budgeted, because the amount of manpower and the amount of human hours which will go into the development of the software will change with the changing requirements, which is going to definitely which is going to affect the budget. So, the budget, another thing is the budget. Then the software must do what it has been designed to do, and it must not do what it has not been designed to do. Therefore, this is a norm of acceptable performance, that is, it should perform correctly the operations which it should do, and the operations should be error free, bug free, and should be as expected by the users. The outcome of software engineering should be a satisfied customer or a satisfied client company after the using of your software. So, basically the economies of all developed nations, they are dependent on software, and more systems are software controlled. So, software engineering is concerned with theories, methods and tools for professional software development. So, we will see the different types of softwares which are developed, like there could be a simple customized software for management of a database of employees or for the payroll management or things like that, or there could be a very complicated embedded system for which a software is to be written and coded, and then it is to be working with the in the form of an embedded software system or an embedded system. So, all that needs to be taken care of. So, basically it is more a lot more than just writing the code. It is a lot more than writing the code, because it will involve a number of steps. The first and the foremost thing that we talk about in software engineering is that it is an exercise of problem solving. So, when I say the word problem solving, it means that a problem is given to you and you are supposed to provide a solution which is cost effective, timely and correct and efficient solution to the user. Now, when you are talking about problem solving, basically the first step which comes in problem solving is analysis. Analysis basically means to study the given problem, to study that whether that problem has some sub aspects also or not, some parts of the problem are there or not, and then to create and to deal with each of those parts as individual levels. So, to look at the problem and its sub components or sub parts is a very important thing before you actually start solving that particular problem, to understand the nature and behavior of the problem. After this, once you have analyzed the problem and you have identified the sub parts of that problem, the next phase which comes is that of synthesis. Synthesis phase, you will actually define the different components and you will find out a solution, you will try and work out a solution, at least theoretically, to solve the problem and to solve the issues of all these sub parts. Then we have techniques, methodologies and tools which are to be used for solving those problems. Now, when we say techniques, technique could be a simple algorithm, or it could be a simple mathematical step or a theorem which will be used to solve the problem. And methodologies are actually a collection of several techniques which will be employed in order to give the solution to the problem. There are several tools which are used. So, all those tools will be employed, which will be used at the different stages of writing the program code, of running the program code, of testing it, verifying it and also implementing it. So, once the problem solving exercise is done and we try and reach at a particular stage, the software engineering also becomes a modeling exercise. It is a modeling exercise because you have to develop a prototype or you have to develop a simple model of the way the user wants to work on it. So, basically it is a foresight, it involves forethinking to create something which the user or the client himself is actually not aware of, that what the system is going to be. Then knowledge acquisition exercise, it becomes because a lot of data and a lot of business rules, procedures are understood and undertaken by the software development team, and once they have built that kind of knowledge base, only then they will start working on that. And the rational management is important, that is to convince the client that yes, they require this kind of a system, that yes, they require to put in that much amount of money, time and effort in developing this software system, and it is going to benefit their business in the long run, and it is going to ease their life in the long run. So, the rationale has to be convincingly conveyed to the concerned client and his or her parties or employees, if any, so that the acceptance level of these people will increase, and they will easily take up this software, and they will try to use and learn the software as a part and parcel of their daily code. So, software, when you talk about softwares, a very important aspect that comes around are the costs. Now, we understand that software is a very expensive affair, because in today's world, see, gradually there has been a drastic change in the cost of hardware versus or vis-a-vis the cost of software which were required to create an automated system. Now, today when we are talking about an automated system or a computerized system, the maximum part of the cost of the project, maybe 70 to 80% cost of the project can be attributed to software cost, and about 10 to 20% of the entire project cost is attributed to hardware. This is because that over the years the cost of hardware has come down, but that of software hasn't come down. So, therefore, we can understand that we will run software worth crores of rupees on hardware worth 1000 or 35,000, 40,000. A computer hardware worth 30-40,000 rupees can be used to run software which will value about in crores of rupees. So, we can understand that software becomes a very expensive article in case of an automated or a semi-automated system. So, generally the cost of software is calculated as kilo lines of code per person per month or per unit time. So, kilo means how many thousand lines of code are written by a person per month. So, a very good software programmers may also sometimes only write 1000 to 2000 lines of code per month, which may also be good. And if you are talking about the different types of system for which software is being developed, so then this number can vary greatly. So, the 1000 lines of code which are written by a person per month will be calculated as software cost, because when software cost is being calculated, since software is completely service based. So, it is the softwares are developed by people. So, the only resource which goes in development or in production of software products or in creation of new software are human minds. So, the cost of the software is only calculated according to the cost of the manpower which goes into developing it, or in the manpower which goes into writing the code. So, these software costs will often dominate the entire system cost, and they are very high as compared to the hardware costs. So, software costs are more to maintain than then also it takes more cost or more money to maintain the software than it takes to develop it, because it is basically in software maintenance is very important, because it is an ongoing process, and all the time some or the other requirements of the users will come in, and for that the software has to be ready at all times. So, maintaining the software will cost even more. So, resources are to be deployed for maintaining and keeping up the software. So, software engineering is actually concerned with how best in the cost effective manner the software can be developed. What is the most cost effective way in which software development can be done and new softwares can be created. So, softwares are generally termed as that they are late and these are unreliable. So, late meaning there is a term which is commonly used, that is known as runaway project. So, runaway project term is used for projects which are not delayed or which are not slightly out of budget, but those projects which have gone out of control with respect to their time deadlines and also with respect to their financial budgeted amounts which were there. So, such projects which are known as runaway projects, they need to be held and they need to be converted into some sort of control mechanism, so that they can finally be deployed to the client, and also the cost effective methods are to be devised for such kinds of projects which are losing all their time and budget constraints. So, what it is supposed to do is, now software must always be important. It is always important that the software should be accurate and efficient. That is, it should not do what it is not supposed to do, and it should do what it is supposed to do. So, failures will occur because of bugs or errors. Now, the point is that these bugs or errors in the software, they do not creep in at a later stage, but they are actually introduced at the time of software development or while the code is being written. But the point is that these bugs or errors may come out or they may surface up even after years of the client using the software, because there are certain bugs which will create their effect only when a certain condition of input and output is met. So, failures will occur due to bugs and errors, and these failures need to be met, because if these bugs will cause some kind of behavioral malfunction in the software, it will create problems for the client, and sometimes these bugs may be very difficult to detect also. So, there could be errors which could creep into the system and which can cause fatal problems for the client's data and the procedures which they are following, and sometimes these go unnoticed also. So, therefore, the softwares should meet the criteria of being on time and also the condition of being reliable, that is, they should do reliably, they should do efficiently, correctly, they should follow the functionality which has been which they have been designed for, the efficiency which they have been designed for, they should follow that. So, software products basically they are classified as into different categories. So, we see that we call certain products or certain softwares, they are known as generic products. These are standalone systems which are produced by development organizations and sold on the open market to any customer. So, these are generic products. So, this is one specific product which is available in that area, which have sort of monopoly, which becomes so popular, and then everybody and anybody who needs that kind of functionality will have to go and buy that software. So, it is not created for any specific client or any specific person, but these are very general products and which have very general purpose or broad based functionality which can be used by any of the any person who is there, and these softwares are available in the open market for anybody to buy and start using them. The next category of software products which are also very popular these days, these are customized products. So, these customized products, they are basically systems which are commissioned by a specific customer and developed specifically by some contractor. So, they are actually according to the very specific needs of a particular client, a company or an institution, and these will meet those requirements. So, these are not general purpose or broad based which can be used by any other client, but these are uniquely designed for a specific set of requirements of a specific client. So, these are, and therefore, this customization products, product customization or these software development tasks for specific requirements are taken by the companies, and they are depending upon the size of the project, there are different companies which will access that. The next set of quality attributes that we will be discussing after a short break. Till then, thank you.
With this note, thank you, ma'am. Thank you so much for giving us this session on software engineering. Dear friends, there is a lot more for you. You are requested to be with us as we are back after a short break. Thank you. Hello friends, welcome back to this session. Friends, as you know that today we are giving you in-depth knowledge on software engineering is, and we are trying to explain you what software engineering is. Friends, for the discussion on the topic, we have with us in our studios Dr. Pavitra Bharadwaj. Dr. Pavitra Bharadwaj is Assistant Professor in Department of Computer Science, Jesus and Mary College. Friends, if you have any questions, then feel free to talk to us through our toll-free number. Our number is 1800110430. I repeat, our number is 1800110430. Now, I would like to welcome our guest, Dr. Bharadwaj, once again, and would request her to continue further. Hello, ma'am. Welcome back.
So, we were talking about the different types of software products which are available. Now, we will talk about the quality attributes which are expected out of a software. What are the different attributes which a good software must possess? So, to name a few, first is maintainability. Now, when we are talking about the word maintainability, we must understand that maintenance is one aspect of software, and it is quite different from maintenance of any other physical or mechanical machinery or products which are used. Because any mechanical or physical machinery which are used in the in any institutions, they undergo physical wear and tear. So, they face a problem of aging, and therefore, the maintenance required for them is different. Whereas, when you talk about software, software is an intangible entity, logical entity. So, there is no problem of aging per se, but the problem which will come in a maintenance part is that the software has to continuously keep evolving. There is a very famous law which we say, that law of software evolution, that is, the environment in which the software is working may keep on changing. It keeps on changing very frequently, and because of which the changes in the environment, the software has to change, and because then the software has changed, so again this changed software will impose some changes in this environment. So, this is basically a cyclical process which goes on. To understand this, we can understand like that for example, we have a payroll management system. Now, if it is a payroll management system, when the company's policy or when the salary structure will change, or say for example, a new pay commission has come in, so the way the salaries are calculated and the way different allowances are given is changed. So, all the places where such software was running had to be changed, the various criterion had to be changed. Say for example, when GST was launched, so the software had to be there were several changes which has to be incorporated into the software to take into account the changed business environment, because and the business rules and the government regulations which came in through the change GST. So, therefore, this kind of maintenance will go on because the market or the environment in which the software is working will change. Another kind of maintenance which is required is because of users' requirements. Many a times it is seen that once the users are stating their requirements, they are themselves not sure, and once they start working on a product, on a software for a certain number of days or a given period, then they realize that certain requirements have not been taken into account or have not been mentioned to the software vendor when the development or when the requirements were being stated. So, those requirements are now to be taken into account so that the software meets the functionality. So, such kind of maintenance activity will go on till the time the software has been used by the user or by the client for a considerable number of period of days or months or years, and such kind of maintenance is known as adaptive maintenance or it's a corrective maintenance. So, basically maintenance is an ongoing process which will go on, and a software which can be maintained, which can be corrected, which can be tested and which can be reused again and again even after changes in the business environment is said to be a good quality software. The next important quality of a software is dependability. Dependability means that the software is going to be relatively or mostly bug free, and it is the outcome of the software can be easily depended upon, can be easily verified by the client or the company, and it can be used as for future purposes, it can be used for efficient decision making. The next quality which is used is efficiency. Efficiency means that the software will give the desired amount or the desired results using the least amount of resources. That is, in the minimum resources it should give the maximum output. So, if the software is requiring certain resources, then it should justify or it should very well meet with the requirements. The next is usability, that is the software should be usable and it should be reusable by changing certain parameters, and it should also be user friendly so that it becomes easy for the customers to learn the software, how to work on the software and to use it to the optimum. Functionality is again another important aspect of the software, which means that the software should be suitable for the particular company or for the particular scenario for which it has been developed. It should be accurate, that is, it should accurately meet the requirements and the goals for which it was created, and it should provide the requisite amount of security features to the client's end. So, the client's data and procedures should be secure even when they have been transported to the software. The next important feature is portability, that is, the software should be able to run on different types of hardware, different types of operating system and different kinds of other software parameters equally well. So, it should not be very hard bound software and it should be flexible in its working, and there should be a lot of adjustment which can be made in the software if it is to be running on a different kind of computer system. So, it should be platform independent software which is aimed at, so that it can be used efficiently and dependably on any kind of platform, hardware, software platform which it is providing to. So, if a software meets all these requirements, then the software can be considered as a high quality or good quality industrial strength software. So, it is very important to note that product characteristics, or what are the importance of these characteristics which we just discussed on the product. So, the relative importance of these characteristics depends upon the product and the environment in which it is to be used. In some cases, some attributes may dominate, in other cases some other attributes may dominate. For example, in safety critical real time systems, the key attributes may be dependability and efficiency. In other kind of systems, the importance could be given to usability. For example, if you are working for a governmental setup, so there the software, the most important criteria to be met is usability, so that the users, they can accept the software and they are not dragged away of the software because of the complicated interfaces, or because the software is too difficult to understand and learn by the people. So, what kind of people are going to use and in what scenario the system is to be used will determine which attributes are there. So, sometimes we have to go for a trade off between certain attributes to achieve the other attributes. So, sometimes security may be a prime concern, and because you want to lay more stress on security, so then you may make the system less portable, so that it cannot run on any and every system, and it becomes a little more difficult for people to run it across system, because you want that system to be limited in its use. So, cost will tend to rise exponentially if very high levels of any one attributes are required. So, this is very important, that once the user specifies that which are the most critical attributes for the software that the user expects, the costs accordingly are to be calculated. For example, if it is a software which requires round the clock availability, then the software costs will incorporate the other running costs and the other costs which are required for running a 24/7 system. So, when we talk about software products and we compare them with normal programs, so there is a lot of difference between a program and a software product. So, when we say a program, it is usually small in size, it may be a few hundred lines of code maximum, whereas when we are talking about a software products, these are really large and they may incorporate several other programs in it. So, one software product may incorporate multiple programs which will run together and will communicate with each other in order to work. Next is the author himself is the sole user in case of programs. So, programs are generally written as an academic exercise or even as an exercise in the companies, but basically the author only runs it and author is the owner of that. But in case of software products, so these are aimed to be used by a very large number of diverse users. So, they are more diversified in their usage and they have to be more simplistic in their usage. So, the programs are generally done by a single developer. So, a person or maybe two people can sit and write down a few lines of code and then run it and becomes a program. But software products are very complicated large systems. So, certainly they require a good team of developers which are going to work on them. Now, software will lack any kind of proper user interface, because as we just discussed that the author himself is going to use the program. So, the author or the programmer who has written the program does not need a very robust interface, he can just run the program through the console and see the results. But when we are talking about software products, so they have very well designed, very rich interface, because it is going to be used by a number of users, it has to interact with a number of users. So, it will be a very well designed interface. Now, programs, they will actually they do not have any documentation, and even if there is any, that is only in the form of some comments which are written along with the code for any kind of readability and for a simple explanation. But in case of software products, these are properly documented and a full-fledged user manual is prepared for them, so that it becomes easier for the future users to work on the software, to understand and to learn all the different aspects of the software. So, a software product will always come with a well documented user manual and a step by step guide as to how to use the software in the most efficient manner. Now, programs, they are actually done using an ad hoc development. So, as and when the requirements will come, the program can be extended, it can be its functionality can be extended, enhanced, and new modules can be added to it according to the requirements. But software products, they have a very systematic approach of development, and before the work starts, actually the document is prepared as per what all the software is intended to do, and there is a very finite scope of activities and scope of functions that a software is expected to do, as a software is expected to follow, and the software clearly follows only that kind of approach and that kind of scope. So, it is very finite scope which a software product will take up, whereas programs can be extended by any kind of simple addition of modules to it. So, basically what we are trying to say here is that a software product is a very robust, large collection of program which is run, which is used by a very good number of users and developed by also a good number of developers who work together as a team, and there is a systematic process which is required for the development of software products. So, this systematic procedure which will be required for development of products will come under the purview of the software engineering domain. So, if we look at this graph here, we can see that as we try and increase the efficiency of the product or of the software, the costs will go high, and beyond a point the costs will go high, the cost will increase or escalate at a very high rate. So, therefore, cost benefit analysis is a very important part of the software development process, because the amount of efficiency or the amount of benefits that are accrued by increasing the cost after a point has to be done after discussion or after consultation with the client. So, the cost benefit analysis will also be a very important aspect of software development cycle. So, when we talk about the software engineering approach, basically we are saying that the quality and productivity of software is dependent upon three vital facets. These are people, processes and technology, and this particular concept is known as the iron triangle concept, and according to this, the quality and productivity is dependent upon people, because as we said that software is basically a service oriented industry and a knowledge based industry. So, which is clearly dependent upon the knowledge of the programmer, upon the will, upon the work of the programmer, who is going to write, who is going to work on the desk and write the lines of code. So, the person who is developing the software is one of the critical elements in determining the quality and productivity of your software. The next important aspect are the processes. The processes which are required or the processes which are used in the company, they should be well documented and well understood, not just by the software developers, but also by the people of the company itself. Sometimes it is observed that the people who are working in the company for years together are themselves do not have a very clear picture of the holistic way in which the company is functioning. So, the understanding of the business processes and methods and rules which are followed by the company, the business rules which are followed is very important. And the third and very important aspect of software engineering, of course, is the use of technology. So, the software engineer must use the latest tools, techniques, methodologies for employing those tools for providing the correct and the latest state of the art solution for the user's problem. So, if these three aspects are dealt with carefully and are dealt with care, then certainly the quality and productivity, which is Q and P, quality and productivity of the software which is developed will be very high. So, when we talk about the software process, basically software development is a structured set of activities which will be required to develop a software system. So, we have to follow a given set of activities, and each activity is very crucial and is very critical in the development of this software process. So, each of these can be determined as the phase, and activities will actually vary depending upon what type of organization is going to use it, what type of system is going to be built, what are the different requirements of the organization, and once these steps have been designed, they have been decided, they need to be explicitly modeled, so that the people or the person who is working on the software development process, they are well aware and they can easily understand and manage the entire flow of the process. So, in case of software development, we generally follow 4 major phases. First is the specification phase, the second is the design phase, the third is the validation and testing phase, and the fourth is the evolution phase. In the specification phase, basically it is the requirement analysis phase. So, in this phase, the most important aspect, that is understanding what is the user's expectations and what is the user's requirements from the software is done. Sometimes the expectations may be unrealistic or may be something which is not required. So, it is again the task of the software developing team to make those expectations as real as possible and to make those expectations and to make those requirement understanding as clearly documented as possible, because this is one phase because of which many software projects have failed, because of lack of understanding or the difference of language or the difference of the terms which are used by the software developer and that by the client. So, requirement analysis will clearly lay down the specifications of the system, and it is a clearly written document which will come out of this phase, which will set the stage for the next stage, that is the design phase. So, once the specification and the requirements have been understood clearly, the next phase which comes is the design phase, or how the programs are to be written or how the entire system is to be designed. So, for this what tools or what programming languages or concepts are to be used, all this is again decided. Validation and testing will come, that is how to check whether the results which are given by the software are correct or not. Different kinds of testing tools and methods are used for validating the correctness of the software which is developed, and the final stage which comes after the implementation is evolution. That is, each time once the system has been implemented, there will be several changes to the system that will be made, and the system will keep on growing and evolving with time. So, the next implementation and post implementation phase is also very important. So, in this case, as we just discussed, in the specification phase, the requirements are set out, constraints on the system are set out. As I just said, the realistic requirements and the unrealistic requirements are sorted and are made very clear. In the design phase, a model of the system will be prepared, and after that in the manufacturing stage, the system will be built according to the model which has been approved. Then the testing stage, the system meets the requirement specifications or not is checked, and then the system is finally installed, deployed and delivered to the customer, and we ensure, the team ensures that it is operational, it is working, and after that the faults in the system are discovered as and when by the user is using, and these faults are recovered. So, when we talk about emergence of software engineering, basically we will talk at the different ways in which programming techniques have evolved. So, during the 1950s, that is the early programming, computer programming days, the programs were basically written in assembly language. So, these programs were limited to about few hundred lines of code of assembly code, because assembly language coding was a very cumbersome and a very tedious task, and instructions had to be hard coded and they had to be fed into the system, and then these programs used to run. So, assembly language programming was the first form of programming in which every programmer developed his own style of writing program, and this was an exploratory exercise for the programmer also, because there were no set rules, there were no set ways in which programming could be done. So, each programmer worked according to his intuition and his understanding and just sorted out the process of program development. After this, that came in was the high level programming, that is in the early 1960s. So, high level languages like Fortran, Algol, COBOL, these languages, these were more English like languages, therefore, these were known as high level languages, because the commands in these languages were written in they were actually English words, and they reduce the development efforts greatly, because people now use the same language to talk to the computer as they were using themselves. So, this software development style, this again still remained exploratory, because people used to make different types of commands and statements, and then they used to run and see. So, typical program sizes were again limited to few thousand lines of source code. So, these programs were also very long, and therefore, the number of errors which were experienced by the programmers were very high. After this came the control flow based language design. So, in control flow based design, which was in late 60s, the exploratory programming style was used, and it proved to be very insufficient, and it became very difficult to write cost effective and correct program, because as we just said that in case of exploratory programming, a lot of errors came inside in the lines of code, and it took a lot of human time effort to rectify those errors. So, a new method was devised in which the flow of the control of the program was going to be decided, and it was not an exploratory technique. So, programmers found that the programs written by other programmers were very difficult to understand. So, to cope with this, they said that special attention to be given to the program's control structure, how the program is going to be controlled, that is very important. So, in this case, a program control structures indicated the sequence in which programs instructions were executed, and to help design programs having good control structure, flow charting techniques were also developed. In this case, the go to statement was used quite often, because this statement it modified the flow of the control, and it modified the way instructions were executed one after the other. So, this was very cumbersome, although, because a lot of sequence control instructions could not be taken up, and it was later on conclusively proved that only 3 programming constructs are sufficient to express any programming logic, that is sequence, selection and iteration. Sequence means one after the other, selections means where there is a fork, that is a condition. So, accordingly the program's control will flow, and the third is iteration or loops. So, it was decided that go to statement was redundant, and any kind of programming problem could be solved without the use of go to statement also. So, therefore, the control flow based design then was changed into a higher level coding scheme, which did not have the go to statement at all, and which only controlled the flow of program and the instruction execution using these 3 control structures. So, in structured programming, basically only 3 constructs were used, that is sequence, that is in one after the other the programs are the commands are executed, the statements are executed. In case of selection, where there is a condition and one out of the 2 statements will be executed depending upon the outcome of the condition, and iteration, which will create a loop and a specific set of conditions statements will be executed till the time a particular condition or is met, or till the time a particular value is found to be true. So, structured programming was a latest development, and unstructured control flows were avoided. So, this now structured programs, they had a neat set of modules, and these modules were actually simple functions, and each of these functions had a single entry and a single exit point. So, these were specific program constructs, and exception handling violations were permitted in this. So, structured programs, they were modular programming, in which single entry and single exit points controlled the way in which a program was executed. The same program was, the same module could be called several times. So, this also facilitated a lot of reusability of code and saved a lot of time and effort. So, it became, these structured programs were easier to read and understand, these were easier to maintain. As I just said, that this required less time, effort, and the less number of errors were used, because the statements became simpler, test and branch constructs were there, and there was if then else and do while and simple loops were there. So, these programs became very efficient and easy to run, easy to write, easy to maintain, and easy to understand by the other programmers also. So, a lot of programming constructs were made during this period, during the 1960s, and later on after that new constructs have been developed. So, we shall be continuing on in this series in the following lectures also. Till then, thank you.
Thank you, and thank you so much for giving us this session on software engineering. Dear friends, if you have any question or feedback, do write to us at info.cec@nic.in. We are taking your leave with the promise that we are going to meet again soon. Till then, take care. Goodbye. Thank you once again.